Alright, so in this section we will cover Linux hard and soft link, also called a symbolic link, and for which we are going to use the ln command. First, let's see what are links. A connection between our file name and the actual data on the disk. And there are two types of links we will cover. So first is, what is soft or symbolic link? So it is a physical file that points to the original file. You can think of it as a shortcut or pointer. For example, in Windows, you must have used these desktop shortcut to start an application. However, the actual data lives somewhere else, maybe in C drive or D drive. In Linux, we do have the similar concept where we can create the shortcut to make our life easy. So let's see the practical. So this is my Linux terminal and I am currently inside my home directory. And I have created a file deep inside the location, which is multi directory 1, then 2, then 3, and then og_file.txt, which is my original file. And this is just a one-liner file. But the point is the long path to access this file. Okay. Now imagine if I want to use this file on a daily basis or frequently, then it's hard to remember the whole location, and also typing it each time is annoying. So to make the things easier, what we can do, we can create the shortcut which is pointing to this original file in my home directory. So I can simply use ln-s, which is for shortcut or symbolic link. Okay, then the location of the original file, which is multi dir 1 2 3 og file. Okay, then name of your shortcut or the symbolic link. So I can give the similar name like OG file and S link to differentiate it or to show that it is a soft link or the symbolic link. Hit enter, that's it. Let's check our symbolic link using ls-ltr. Okay, so this is our symbolic link which has been created, and you can clearly see after this link there is an arrow which is showing that this link or shortcut is pointing to the original file which is present in this location. Additionally, the type of this file is L, which is representing the link or the symbolic link. The best part is using the soft link or your shortcut, you can read and edit your original file. Okay, let's try. Cat, this is our symbolic link, and if I do cat, so okay, I can read the file. If I want to edit the original file, I can use this shortcut og file slink using the vi command. Okay, let's try to edit this something in this file. So edit it using slink. Okay, save. If I try to read both the symbolic link and original file, okay, and cat multi directory 1 2 3 and original file, so the content of the original file also has been changed. So this is the benefit. Additionally, you can create multiple soft link in different locations. So for example, we have already created this symbolic link in this location. I can create the another one. Let's say ln-s original file, then again, and I will give name as link1. Okay, now you can see I have created two symbolic link and both will work in the same manner. If I try to read from the new link, it is still pointing to the original file. So what are some benefits of using the links? Links can be used as a mean of protection for the original file, and we can keep multiple copies of a file without having separate hard copies. So this one we have already covered, that we can keep the multiple copies. Okay, and all the copies are working in the same manner. You can read from there, you can edit the from there. And what is the meaning of protection for the original file? So we have created two symbolic link which is pointing to the original file, right? And your team member are using these soft link or the symbolic link for any operation or for making any changes. Suppose by mistake or accidentally someone remove or delete this link like this. Okay, or maybe I will remove both the soft link. Okay, I will remove og files as link1 as well. Okay, I have removed both the soft link ls-ltr, so there is no link present. However, even after deleting the symbolic link, our original file is still untouched. So if I can simply access it using the original location, original file is still protected. Let's cover a few more points about the soft link. So for that, I will be creating a soft or symbolic link again. So here it is, ls-lt. Okay, so here is our symbolic link. Now, if I compare both symbolic link and the original files side by side, ls-lt, directory 1, 2, 3 original file, and ls-lt, you can distinguish the difference in sizes of both the two files, the links and the original file, which shows that both are two different physical files. So the symbolic link work like this, and it is just pointing to the original file but does not store the actual data. So that is the reason there is a difference in the size, and also the permissions are different and the type of the files are different. Okay, there is one more important point which is related to the inode number. So there is also the difference in the inode number of both the original file and the symbolic link. Let's try this. First of all, with the original file, how we can see the inode number using the ls-li option, li. Okay, so you can see a unique number associated with this file, and let's also see the inode number of our soft link. If you notice, for this original file, the inode number ends with 157, and for this symbolic link, the inode number ends with 672. Means the inode number in case of the soft link or symbolic links are different. But what actually are inode number? So I can explain in short. So for each file, there is a inode number associated, like let's say 1, 2, 3, 4, 5, which represent the location where all the metadata of this file stores. Example, permissions for this file, ownership, size, and the location of the actual data on the disk. Okay, so it store all these information. So in our case, what is happening? For our original file, there is a separate or different inode number which is pointing to this file data, which is the actual data. Okay, let's say, and the soft link we have created is having the different inode number which is pointing to the original file. Okay, so this is the reason why the inode number is different. So there was one more point in the symbolic link definition, that link will be removed if original file is deleted or removed. So let's try this. So our symbolic link is still there. If I remove our original file using rm multi directory 1, 2, 3 and our original file, that's it. And if I again check our symbolic link, so you can see it is showing in red color, which means the link has been broken and there is no pointer left. If I even try to read this symbolic link, it will not work, no such file or directory. So this symbolic link is become useless. So what we can do, simply delete this. Yeah, that's it. Now let's talk about the hard link. In case of the hard link, deleting, renaming or removing the original file will not affect the link. So this is the best use case to keep the backup of any files and the extra copies. And to create the hard link, you can simply use ln command without giving any option. So let's try this and let's see how it works. So for that, first I will create the original file. So echo, this is original file, and again in the same location. That's it. Now to create, okay, so there is no link in my current home directory. I will simply use ln, then the location of the original file, multi original file, and then your name of your hard link. So let's say you can give any name, og_file link, like that, in just to differentiate. So our hard link has been created. If I see the type of this hard link, ls-l and og, so it looks like a normal file, and similar to symbolic link, we can read and edit the original file using this hard link. Okay, let's try that. Cat og file. Okay, we can read it, and if we try to edit like vi and edit it using link, okay, save, okay, and again, okay, so this has been changed or edited, and let me check read from the original file. Okay, so this also has been edited. So in case of the hard link, so what are the similarities and what are the differences? Let's cover that. Let's first see the inode number. So ls-li. So let's first see the inode number of original file. Okay, so this is the original file, and then our hard link. So in case of the hard links, both the original files and the link created will be having the same inode number. Also, there is one more change, that the size of the file is also remains same, and also other details like the permissions and all. So what is the reason of having the same inode number in case of the original file and hard links? Because when you create the links, it is pointing to the actual data or the file data, but not pointing to the original file. Okay, so this is the best use case of the hard link. So what is the benefit of using this? If I rename the original file, let's say, okay, let's try this using the mv command. So I am changing the original file name from og_file to og_new files. Okay, in this directory 3, there is only one file, which is og_new file. Even though if I try to read the hard link, which is og_file_h link, okay, this gives me the same content and is still accessible. That means renaming will not affect even if I remove the original file. Okay, removing the original file. Okay, so there is no impact even though ls-lt. So og file hard link is still there, and still I can access it and read it or perform any action. So this may be useful if you want to keep the multiple copies or as a backup, right? So even the one copy is deleted, the other is still there to access your data.